All right, welcome. Thank you, guys. What would you like to consider or do here?
This is knowledge management, not the
Yeah.
training.
It's we can go to education if we want, but we're in knowledge engineering.
Just
Although
reviewing the
I
agenda you've
got
got on the screen.
George mentioned the essential David Bohm. I got the physical of this book, so eventually I'll discuss that. Yeah. So let's see. This was last time.
I
Peter,
think the
of
last
course.
meeting we ended up mainly talking with George about content rather than knowledge management. So
Yeah. Yeah. Peter made the 2-minute video, talked about P3AF, value sensitive design. Okay. So Tom, we could discuss some aspect of where you're at, or Rob with SCA, or some other topic.
Trying to remember, I think I sent out a document
Oh, yeah.
to something I wrote 10 or 15 years ago. I'm trying to remember exactly what it was.
Yeah. I have it. I'll bring it in.
Either Daniel or Rob has any background in software.
I worked
That's
in
not,
IT, yeah, for decades, but mainly I went up the database developer, and then DBA administrator, network person, and then ended up in supporting enterprise systems. So that's with some programming in there.
I'm just seeing more and more of similarities between developing software and systems in general.
Yeah,
Latest
well,
thing has been the quote boundaries, which I see more as interfaces. And there's certain architectural benefits from an interface. I think Simon in Sciences of the Artificial talked about some of them. Possible target for a paper, but not ready to do it just now.
So what is this report that you've sent round? Can you give us a nutshell summary?
Yeah, I'm trying to. I don't know if you can see this or not.
The ideal of coherence, right?
yeah.
Called an executive report from Cutter Consortium. They're like a consulting outfit, but they're sort of on the cutting edge of ideas. And a company that I work for, some of the people there did a number of them when I got involved as well. So this is just the idea of things fitting together, which it appears that the universe does all fit together, but our views of it don't fit together because we develop different parts at different times with different groups of people. And so it's fragmented. So this is sort of the opposite of fragmentation, putting things together in a way that they're coherent. So I'm not sure what else I should say. If you get a chance to read it, have some questions, we can talk about it another time maybe. But I see it fitting well with systems. I'm an advocate of modeling And one of the benefits of modeling is that you can make things coherent if you model in the right way. You basically have to start from scratch, and everything you put in, make sure that it is coherent with everything that's already in. And this doesn't mean tacking it on and changing whatever you're putting in, but it means reevaluating the whole each time you put something new into the model, which most modelers can't do. In business anyway, there's usually already a lot of things that have been established and they can't be changed. So it's hard to make things coherent. But if you're thinking or doing theoretical work, you can do it. I've been trying to write this up in a better way for some time, and I haven't gotten it all together yet, but I'm hoping to get time to work on it shortly.
I mean, two approaches come to mind without having read the report. So one is enterprise architecture and how there's initiatives within organizations to try and tie together different systems through some sort of effort at many different efforts at different levels, with mixed success, because quite often they're fighting against project managers who just want to roll out and deliver something quickly without much consideration or cost involved in trying to connect it up. So that's one.
I'm quite familiar with that. You're absolutely right. I think of it as a long term and a short term, and keep business running. You have to do things in the short term, and so there's a lot of people that are very short term oriented. They just want to meet the next deadline, get the next step done, and then there's people who think through and say we're doing it completely the wrong way. We should be doing it differently, but it requires a big change on a long term program. Yeah. And it's just always a struggle. So I see sort of the same thing with systems. I think we really want to understand the whole, and the whole is the universe. Now we can't model everything in the universe in full detail, but we can determine how it's all sort of architected, how it fits together, the process in which it developed. There's a lot of people that are looking at that now, but it's hard to put all that together and not get hung up in some little piece of it. So that's seems to be the challenge that interests me at the moment.
Well, the second example that came to mind was, I think, an initiative called CHANS, CHANS, coupled human environment, coupled human and natural systems. And I think there was a big push for this back in 1999 onwards for about 5 years whilst the funding was in there. But that kind of represents a different approach of kind of like best of breed, where you do have all different systems and then you work at coupling them together through interfaces and protocols in some less than ideal way, but still effective because it's formal and controlled. So it seems to me that there are multiple different ways of tackling this aspect of working coherence or operational coherence.
Yeah, that's a good point. We already have a lot of fragments, valuable fragments. So one approach is how to put them together. The existing ones would be one approach. Trying to develop another one in which everything would fit is a different one, but it's long term.
I thought you were going to allude to the work of the software ontologists, and there's a huge community. I know you've mentioned this in a couple of times, but the data and software ontologists have always tried to tackle these marrying up of ontologies and underlying top level ontologies or over top ontologies, like John Sewer and that still seems to be in its infancy, but a lot of efforts made to try and develop that side of things as well.
Yeah, I know what you're talking about. I'm a little bit familiar with, I'm not, by far not an expert in ontology.
In a way, the scientists have the laboratory for their controlled tests, and systems people maybe have the real world for real world testing. But in a way, I think the IT or computer environment is another, and the virtual reality is another testing bed for systems, to test for things like truth and coherence. So I think systems people should pay a lot of attention to software ontology and computer development as one of their acid tests or testing grounds for the validity of their systems ideas.
There's someone that's written something called the basic something ontology. It's supposed to be very
Basic
simple.
formal ontology.
Yes, I know some other
BFO.
people that are familiar with that. I have looked at that, and in looking into him, I can't remember his name, but he talks about, or he pointed me out to some work that's being done to try to tie, I think initially mostly medical research together, because the government has spent a lot of money on research projects, and they often are in different parts of the discipline. They use terms in a different way. They're not based on a single ontology. So they have tons of data, but it doesn't all fit together. So they're looking at developing an ontology so that everything can be put in, in a way that it fits together. And they get more bang for their buck. How seriously this is, I haven't looked into it in great detail, but again, that sounds a lot like what we need to do as systems.
Well, I think it does, because I think it brings us nicely back to one of the projects that we've talked about in this knowledge engineering group about taxonomies and classifications of systems and system sciences and formal sciences. And so that touches on, and that is part of a group of terms that touches on ontology as well. So yeah, I think it comes back to one of our active projects, which I'm hoping Chris Merrill will get back into, be involved with, because he expressed an interest in that.
Yeah, that's awesome. Thanks. Just a few notes, like to kind of bring things in. Sumo by Adam Peace. He has curated a long, I'm sure we've talked about this before in these meetings, but I just find it really interesting how it's structured like a Lisp program. And so rather than being based upon like Marrow topology or classification declarative schemes, just descriptors, it's like a program, so then you can do proof and higher order logics in the ontology, rather than having the ontology be basically like a structured annotation tag list, which is important. But then if you want to check if something's complete or look for adjacent possible or incompatibilities, there's the whole secondary question about encoding the logic of the ontology components. And so Sumo just encodes the basal ontology components as programs with this KIF knowledge interchange format. And that's one thing that we're like trying to work towards or with, like in parallel to other ontologies. But certainly this like question about resolving and like mediating amongst them is a big question. And system science is you know, its own worthy target of that, and would help us greatly in other domains. Like to have the classification of different ways of talking about parts and wholes. Otherwise, in the biomedical ontology, it will only, it will be unlikely to have a, there will be, it will be unlikely that there will be a compatible parts and wholes implicitly or explicitly in the biomedical as in another discipline. They're just going to come to their own solutions. But if there were the systems template or merge approach or something like that. But just to speak to the point that Rob made. Greetings, Randall and Peter.
Hey, how you doing?
Hi.
Tom emailed this article, but other than that, we can just talk about whatever people want.
Well, I was interested in what you're just talking about, and I was just wondering if um, anyone was modeling ontologies as parts of a larger whole, sort of, and thinking about, moving between them as a kind of code shifting. And that in itself might have its own separate ontology. Does that resonate with anything? Anyone?
It does resonate with what we've been talking about, and I'm trying to remember some of the conversations that I've seen in the ontology forums, and my immediate reaction is that I don't think systems ideas are well represented in the discussions, and I think they could add a lot to the ideas being discussed there. But I think that's also partly the systems community's fault in that they haven't really got a coherent theory and message to offer up, which brings us back to sort of a general systems theory in my book anyway. But yes, it does resonate, definitely.
Well, yeah, that's interesting. I don't know why it is, but I see ontological ontologies as part of a system, and say an epistemological paradigm or qualitative paradigm, right? And these sort of emerge out of systems of thought, and discourses, right?
It is quite quantitative, I think, as well, because I don't think the software ontologies and the thinking handles context very well at the moment.
Right.
I've
Well,
worked a good bit. I've worked a good bit with UML. In fact, the models that I've built are based on UML. And UML has a sort of ontology, I guess a very general one. But a lot of things are already well defined, and you can customize it fairly easily in a number of different ways. So you can add to the ontology. It doesn't have everything that system needs, but it has a subset of it. And they developed their ontology on a series of meta models. There's a meta model that describes UML, and there's a meta model that describes meta models. It's like self-defining, so it doesn't go on to infinity. There's a series of 4 meta models or modeling languages that all fit together, and that's proven to be pretty workable. They have quite a family of languages now built all on the same meta model. So they're interchangeable to some degree. And one of the things you can do with UML, I don't know how much it's done, but you can do, trying to think of the exact term. It's like translation or transformation. So
Mhm.
you can define mappings from one language to another language. So you could, in theory, do like a model in chemistry and a model in biology, and do a common model that you could then translate back and forth. So that put both of them into a common model. So the idea is interesting. Whether you can actually do it successfully, I don't know. But they've been dealing with some of the same issues. There's an idea there that you need to develop things bottom up, because there was an earlier stage of software where they tried to work at a higher level, and it ended up not being successful. And they did the opposite with UML, went down to as low as possible, built everything up on a solid foundation. And that seems to work a lot better. So I often think some of the work that's being done with systems is being worked at too high a level, and it's using ideas or terms that are not well defined. And that's makes it hard to be successful.
Well, yeah, the fluffiness of natural language words is much more fluffy than the more formal languages of mathematics or computer programs and standards, for definite.
Yeah, that's very interesting. Just one note on the natural language part. The information content can be very high statistically. However, natural language is rarely a formal program, but that's where formal ontologies excel. And then, like, knowing how to integrate the statistical, numerical, natural language aspects and visual imagery, like GPT, the vision capacity, but then these with formal systems. And
Yeah, that's a different kind of epistemology or epistemological approach, where you're looking at the qualitative expressions in a language and relating them to each other. And that process works across languages, right?
yeah, that's a very good point about across languages. One approach to deal with that is kind of make a language of its own, like math, with its notation. So different natural language speakers can learn math, but probably having, the letters a certain way still is probably easier for some people to see and all these different things. But it's like, but the substance of math is not really notation dependent. So especially now with the generative possibilities, it's increasingly important to have the real knowledge representation be at the right level / of the right type to put space between, like, the natural language expression and the meaning.
Right. Yeah. So this sort of veers into some like almost subjective issues, like what's the content of your model? What are the constituent um, training pieces that are somehow reflected in the internal model structures.
It does it did tickle me when I looked at set theory. With its elements and its defined set, but the set itself is just defined with a lot of natural language words. The axioms are defined with lots of natural language words because there's, by the very definition, there's no mass to describe the axioms. They have to be described in human terms almost. And so yeah, we need both really. We need, even in very formal systems and computer programs, we still need explanations because of the human element involved, and because the humans are the ones defining the frames or the formal structure around the language.
Right.
One piece of sumo on that, not like I believe that this software solves this problem in the general case, but just how it's addressed in this is like, if you have an ontology that describes how things are associated, it still is going to come down to like, there's a column of data and it says year, and year is a type of this and that, but then how exactly it inherits its properties isn't in the tag system. And so it just embeds what the thing can be at the bottom layer in terms of a program, so that the like, it's more like a variable, so that's what facilitates translation, because like plain shouldn't be linked through natural language descriptions to other, then it's a translation mess. But then the plain thing is like a program that can have variables set for English or for other languages, but the logic is separated from the bottom layer from what the thing is described as in the variable. I'm not expert at using it, but I just see this as like as one formal scheme. Purely descriptive schemes are probably way faster and way more available, but they're also way less structured.
Never heard of sumo, but I'll look it up and see what I can learn. Brings to
Peter?
mind,
Oh.
some years ago, there was work started on a ontology for the web to allow more formal communications through the web. I haven't heard anything about that for quite some time. I'm wondering where it is.
I think it's going strong. I think companies like Google are really pulling it all together for their own purposes of inquiry and knowledge searching and connecting up. They're almost leading the development for obvious reasons.
They're sort of split out by company.
I think there are multiple contenders, probably.
What is this? Or any other topic?
You put a link to Tom's paper in the notes, did you?
Yeah, I just I put the whole thing in this page.
Oh, you put the whole thing in there. Because I do wonder if it's got any suggestions for the systems community about for us to be coherent in any future paths.
What year did you write this, Tom?
Just trying to think. I might have been around 2005. I've got a hard copy of the paper of the report. Got volume and number on it, but no date. I guess that's probably deliberate. So I don't know for sure. But that's only one piece, maybe quarter of the report. I have an executive summary. Maybe I should send that out. It's only 2 pages. You can get a better idea of what everything is.
I think philosophically, aren't there two competing trains of thought? One is, are you searching for absolute truths according to some reference outside, or are you just searching for internal truths and coherency within? Seems to ring a bell from my basic understanding of philosophy. And I think that's an important quandary that every field faces, but systems as well. Are we intending to be coherent and maybe operational, but not an absolute truth in terms of laws of reality, or are we trying to get to laws of reality?
Well, there's another dimension of that, and that is memory. And this also sort of veers back into the subjective aspects of, say, a persistent system. Does it have a representation that may be hidden from external observers that is, sort of represents an an ideal kind of coherence, right? That might be a goal state, for instance.
What, like a universal, as in Plato's universals?
Well, I think that could be taken in a couple different ways. Universal across, I mean, if you have say a multi-agent system, that same representation could be present in each agent, or it may be within a single agent preserved over multiple time periods. So universal in what context? Universal in the context of the individual entity, or universal in the context of multi-entities? And yeah, there's a lot of potential dimensions to that concept.
Sure. It was triggered by the use of the word ideal, but just reaching. So yeah.
Well,
Yeah,
it sort of smacks of some of the long-standing issues in philosophy, and it's sort of like, is it one or the other, or is it both? And
Yes.
yeah, a single truth or multiple truths, and it's all that very contextual, I suppose, the answers to that.
That's very interesting. That's very cool. One thought that brought up to me is, like, from the empirical, like the biological side. I just remember when I first learned of like theoretical biology, xenobiology, I was like, biology is the study of the actual. We only have the statistical tools. And then the formal needs to be kind of axiomatically proposed. So it has like that arbitrariness. But that arbitrariness is also, it can be understood. and like the empirical coming statistically, the formal, and then also a mundane field at that intersection is statistics. Because however variable the system is in its measurement, you know what form the linear regression is going to have, or you know what form the UML is going to have. So I think that's an example of an interface with formal constructions and empirical components.
Well, in the end, one of the it's fascinating that an integral piece of that is memory. So, unless you have that memory of multiple measurements, over time, you're not able to form that kind of a predictive model. I mean, that's just one way of explaining it, I suppose.
One other piece, this component that Tom mentioned, but also it says here about the all parts being together and visible. This was well, so Rob, you mentioned the human natural ecosystems. The kind of active inference analog is this ecosystems of intelligence, but I believe it's the same thing, just describing heterogeneous interacting systems. And then this was just today. They use this fully synthetic concept to refer to the total description of the generative model, like which is 100% reproducibility for science and engineering. And also this is the one that leaves like the least ambiguity / no ambiguity to the full synthesis. So that was kind of very interesting, because it's like an engineering advance in a way. And so there's a lot of discussion about like building a better hammer and like all of these things. But just but other systems I think are fully synthetic as well. But potentially the UML. And then an interesting discussion about like, well, synthetic, is that like phony slash is that negative connotation or synthesis, and Kant and all of this analysis by synthesis.
Well, it's curious. Another way of thinking about synthesis might be characterized as conjugated relations, right? So you when you conjugate the structure of a sentence or a mathematical expression, there's there's a network of constituent elements that are exist in some relation to each other, but they also exist in relation to other expressions, right? There nothing sort of exists in a vacuum. You could argue that just sitting in a chair eating your breakfast is not an organic conjugation. there's an agent in there actively putting things together. But I think there's another argument that says that's entirely natural. I mean, there's a whole evolutionary history that led up to it. And you could probably causally link, what's happening in this, in this very moment to what happened with the original cell at the bottom of a smokestack underneath the ocean billions of years ago. I mean, there's a chain of chain of being or something like that. It's continuous. So anyway, and then it's all conjugated by what, right? By the sun and the stars and gravity and energetic fields and all these interactions. Is it computable? That's an interesting question. Is it modelable? Then yeah, that's another interesting question. What would it mean to model all that? Well, you have some sort of a synthesized representation that corresponds in some fashion to the unsynthetic one. Represent, that's, the difference between representation and reality. And yeah, the map isn't the territory, but there are some resonances there that have meaning and maybe are instructive in some fashion.
Isn't modeling and abstraction central to the systems approach? The ability to model it should be one of the first questions, almost, arguably.
Well, yeah, I suppose if you're talking about a kind of epistemology, a way of knowing, right? But yeah, that's kind of the first stop in the train journey, right? What are some other stops?
Well, heading towards, certainly, can we put some numbers on it? Can we describe it? Can we model it? Can we represent it in our heads from an instance to an abstraction of the more generalized abstraction of that instance?
Right. Yeah, I like that. So is there do we have like its native capacity to abstract? I mean, just that's what brains do. You have some sort of instance in front of you and it goes through this optical process. Well, more than optical, but multimodal process that inverts it into some sort of representation. And that's an abstraction. The word abstraction comes from the concept of drawing. It's to draw from, is a drawing from a well, right? And it's not, that abstraction is not the reality, but through neurological means, we're able to manipulate that abstraction and make use of it to make decisions, to direct actions, and to make new qualitative judgments. Qualitative would include quantitative judgments like, numbers of things.
And to OODA loop it.
Yeah.
Daniel, sorry, I'm having trouble opening Tom's report. When I click on the links, nothing seems to happen. Is something? I've tried 2 different browsers. Is something meant to?
What? Try this. Just let me know if that link works. Well, we can move these to like a different. Maybe we'll put it on a separate page just so it's easier to read.
Another aspect of software development that often comes to my mind, and related to abstraction and generalization that we've just been talking about. And it started with the idea of reuse. If we go back a little further, first things that were computerized were small pieces of a business. So you would end up with fragments, and they would cover some of the same targets. For example, people or accounts. So you would get something that was developed multiple times. And then people realize, why are we developing these things multiple times? And then we have to pay to maintain them over a period of years. We only want to do something once. So when we start to develop something, we should see whether it has already been developed. And if it is, we should reuse it. But of course, that was always very hard to do. And that eventually changed the idea of we only do things once. So we look at the big picture of the whole business. I think you mentioned architecture, business architecture or software architecture, to say the business deals with people. So you only need one person. You may have specialized people, some that are employees, some that are customers, some that are part of the staff, all different things, but you only need one, but you can specialize it then for different types. But if you structure it properly, you only have everything defined once and only once. And that gives enormous benefits. For one thing, there's no inconsistency because you don't have things defined more than once, so they can't be inconsistent. It's minimum size. But maybe the most important thing is there's only one point of change. So as things need to be maintained or modified or evolved, there's only one place where you can change them. So part of the way of getting that, as I said, is to generalize. So the person, there may not be any instances of person, but there are instances of subtypes of person, like an employee. So you end up getting a hierarchy of subtypes. And I think that's a key for systems as well. And I think of them as generalizations. They also could be called abstracts. But I think that's enormously important to be able to manage all of the knowledge that fits together. And to do that, you have to structure it properly. And I see sometimes 1 or 2 levels of subtyping, but not the idea that there can be a large number of subtypes. And building these hierarchies of subtypes is something that's important to getting where we want to go. In fact, system is one of those. It's a very, very high, very general subtype. there's probably not too many things you can say about system itself, but all of the many subtypes of systems, you can say a lot about. So you have to look at the big picture to get this kind of organization. Anyway, it's my thinking, I think, from years of developing software and carrying it over into systems. Makes some sense.
Yeah,
I'm reminded of the concept of re-representation, which is similar to recursion, or could be similar to recursion.
oh,
And-
what on, please go, sorry.
Well, yeah, and this can be a very useful and economical process. If you only if you find ways to represent things that only represent new entities or aspects once, that would, in theory, might give you the most compact possible representation of the whole.
I like that most compact as possible. I think that's important. Because there's a lot to represent. And if it's in hour-long presentations or videos or something, the limit on how many of those you can see. If you have it in a very compact generalization, you can pick it up pretty quickly.
Right.
Yeah,
It's a double-edged sword, isn't it? We abstract up to make generalities so we can learn lessons from similar situations without having to actually experience them. But we simplify and we lose some possibly potentially crucial details. So it's a double aspect to it.
Mhm.
these are very important for knowledge engineering and for the education side in a different but related way. Just if anyone has any sort of closing thoughts, and then does anyone have any last things to say?
I keep running into the idea of systems. You can only understand the system as a whole. So you have to have the big picture. When we live in a universe, we have to have the big picture of the universe. So that's really needs to be the goal, but it's impossible to do that completely. So have to have a strategy on doing what gives us the most return and somehow avoid getting hung up in individual things that are not so important. That seems to be the most difficult challenge.
Yeah, that really speaks to this kind of empirical, pragmatic, statistical, which is just a map. It's not the territory, but the statistics of the healthcare data do matter. So like it's not disconnected from reality by construction. And then connecting that with that broader epistemic part. And then when you mentioned the re-representation, this reminded me of Agamben's Homo Sacer, where he talks about how the people, the demos, can be represented like a representative, but they can't be presented. They're never presented, but they come into being represented. So that's kind of like an interesting piece. Yeah. Okay, thank you.
Good stuff.
Talk to you till I think no meeting next week as Thanksgiving, but then see you all in 2 weeks. Bye.
Take care.
Okay, thank you.